Hello viewers, today's problem is to compute tension in segment AC and segment CD of a suspending cord which is held by a hinge at A and a hinge at B. So for this, we have to understand first that in this particular segment, this structure is in equilibrium. So if we take movement at any given point, it has to satisfy the equilibrium condition. Okay. So for this, the given parameters are the horizontal distances between node C, D, E are 3 meter each. The total span is of 14 meter and the maximum dip is 3 meter. That is the dip of D from horizontal is 3 meter. The dip at C is YC, which is something which we need to compute. Okay, so the first step is to calculate vertical reaction. So for which we are going to take moment about point A, considering clockwise as positive. So that gives us VB as 25 kilonewton. Then using summation of vertical forces, again since the system is in equilibrium, summation of vertical forces is going to be 0. So VA turns out to be 20 kilonewton. Next step is to calculate horizontal thrust H. Now the horizontal thrust at A and B is going to be same. So taking moment about point D and observing just the left hand part of the section, we can compute that H turns out to be 30 kilonewton. While computing H, just observe the left hand part of left hand part of D, because we are taking movement about point D. It is as if taking section at D and observing left hand side. So the next step is to compute dip at C. Again, as if section is at C and observing left hand side, taking movement at C, YC turns out to be 2 meter. Next, we have to draw the force diagram. Since the given problem is a 2D planar problem, it is a coplanar force problem, wherein the forces, that is tension in CD, tension in AC, and this 10 kilonewton force at node C are acting at one point as well as in one particular plane. So it is coplanar concurrent problem. So where we can apply, since it is just a problem involving, since this node has just three forces, so we can apply sine law over here, which says tension in segment AC divided by sine of opposite angle, that is sine gamma, is in proportion to tension in segment CD. Sine beta is equal to 10 divided by tension sine alpha. So this is how sine law works. Opposite angle needs to be considered and the sine of the respective angle. So from geometry, we can compute gamma turns out to be 71.57 degree, beta turns out to be 123.69 degree, alpha turns out to be 164.74 degree. With all these parameters, the tension in AC turns out to be 36.04 kilonewton and tension in segment CD turns out to be 31.61 kilonewton. Thank you.